Welcome to part 6 of TIS-100. So this is sequence generator. Sequences are zero terminated. Read values from in.a and in.b. Write the lesser value to out. Write the greater value to out. Write 0 to end the sequence. Okay. Okay, so it's quite simple. I'll take in, I'll take in B. I will first write in, then I'll first write in B. So 46, 71, then 0. So this out. So this is the last sequence. So I'll just write this here. Then I'll do, well, I'll check 79 and 71, 79. Sorry, 71, 29. Does 29, then 79. Okay, so move. So there is no way. Okay, there is no way to compare straight away. So I'll say move up right. And then I'll say move up accumulator. Move left. The accumulator. There is no general purpose register apart from ACK. Well, but there is back, but I don't want to use back. How would I compare it in an easy way? Okay, so for the previous episode, it's better to cycle less. So that's what we're going to aim for. Less cycles and less instructions. So the first solution will probably be the one I'm going to stick with. Okay, so we want to get that input from in A. Okay. Okay, there is a way. So if I maybe add them two together, then take it away from up, and then if that's greater, yeah, that like prevents me from using back, I think. And does back is a register, right? Yeah, I think it is. Let's see. Instruction said back is the temporary storage values in ACK. Yeah. And then what does any do? Any is used as source of an instruction. The instruction will read the first value that becomes available on any port. Yeah, I'm kind of like confused on any and last. I think any and last is super useful here though. Any. Because, well, no, it would have been super useful for the previous part? Maybe. Anyway, I don't think it's useful here then. Yeah, I don't think it's so useful here. Okay, how would I do this in one register but reduce cycles? Reduce instructions. Okay, let me see. So this is the previous part. Let me remove that. So if I'm taking in number like 1 and 2. So in dot A is 1. In dot B is 2. I'll move it right, I'll do the accumulator plus 1, which is 3. Then I'll take it away, I'll say 3 minus 2 is 1. But we've actually lost this value now at this point. Because this was the accumulator. Now we have this, so we lost this value. So we'll still have to use back, so I won't be doing that. I'll just... Yeah, okay. I'll say... No, but there... I can't. I have to do something like that. No, I can do that. I'll have to use a combination of that and back. That means, yeah. Okay. I want to store it. So what I'm going to do is I'm going to use the save instruction to save the accumulator into back. Then what I'm going to do is I'm going to add the accumulator from the left with the accumulator from the right. Yeah. That doesn't help me much. Oh, no, I can't. I can't do this straight away, huh? Okay, I guess I won't do that. Huh. 71. And now 117. I wanna... How would I do this? How would I do this? $46 and 71. How do I do this in two registers where back is such a horrible register? Because I can't compare with back, can I? 0, 0. Okay. Accumulator. Negate. Subtract, add, save, swap, move, no up. Just add nil. No, I don't. Okay, well, never mind. Labels, comments. Let's see, instruction sent back cannot be specified. The value of back settings is but receive and swap. Okay, I mean, their logical way would. No. Oh, yes. The eureka moment. So 1 and 2. In dot A is 1. In dot B is 2. So we have ac is 2 at the moment. I'm going to save it into back. So let's say back is 2, right? Then what I'm going to do is I'm actually going to do in dot B minus in dot A. So I guess I'll just do 2 minus 1 equals 1. And then if that's actually, if this value is greater than 0, that means, okay, wait, we want, so this will be the accumulator. So the accumulator now becomes ac1. So this is the value we want to, if this is, so 2 minus 1, we want to write the smaller value, was it? Yeah, we want to write the smaller value. Which means, but we've lost this value already. Because the reason is, I guess I'll use a better example. I guess if this was 4 and this was 3 and this was 1, sorry, 1, this was 3, 3 minus 1 is equal to 2. Accumulator is 2. We've lost this value because we've just taken it away straight away. How about how about... I take it away, I lost the value. I mean, I could give it back again. Just give it back twice. And I actually don't have to give it from the right side. I give it back twice at all times. Even when I don't need to. I mean, that's fair. Yeah, I guess I can use it. I can do that approach. And then JZ, blah, blah, blah. And then I can do, well, like LZ, easy. I mean, something like that. Yeah. Okay. So I'll move it to the accumulator, okay? I'll move up to the accumulator. I'll move accumulator right. I'll move it twice. Then I'll say I save it to the register. I will subtract it from the left with the accumulator. So it'll do 71 minus 46. And if that's greater than 0, if that's greater than 0, JZ. Yeah, if that's greater than 0 JZ, then I'll have to swap to get the accumulator from back. Then I'm going to move the accumulator, swap, move the accumulator down, move left down, so we're gonna get that value. So this is greater than 0, and it's not, therefore we'll swap. Yeah, we'll have to do the check before swapping, that's fine. We'll swap, we'll move the accumulator and that down, and then we'll have to move 0 down. But I can actually optimize it here, and I can say move 0 down. But where this differs is it's gonna stall by accepting the values here. Move down, up, down. Yeah, I think that will work. And then my greater than 0 check. What if it's 0? If it's 0 exactly, it means it's the same value, so 46, 46, which means it doesn't matter which order we give it. So if it just does this, it's fine. So we actually don't have to do a check. So I'll say, so do you want to swap right now? Yeah, I guess we do. I guess we can do this. It doesn't matter when we swap, to be honest. I'll swap just for consistency. And then I'll do the left one first. Then I'll do accumulator down. And I think that should be it. So it saves 71. Then it subtracts it because it's greater than 0. What it's going to do is it's going to have to write 71 later. Oh, it's stalling forever. Why would it be stalling forever? Ah, whoa. Yeah. Let's see again. $29. Ooh. So it does 46, blah, blah, blah. And then it is 90. For some reason, 90 messes up. let's have a look. Where does it mess up? It messes up at 90, at 67. It expects a 90. There is no 90. There is a 90 here? Oh, yes, there is. Okay, so it does 46. It does that successfully. In.B isn't read as much, it seems. They should be going down together. They clearly are not. They are going down together, no? 71, 29, 90 minus 66. Hello? Oh wait, not yet. Not 90. But it raised minus 42, but I've only got 90. Okay. I'm only going to be receiving 2 inputs. And the first input will go down, the second input will go down. That's fine. 0 will always be written. And I thought that instruction's fine. I guess it wasn't. How come? Okay, it receives 2 inputs, 71, 46. It subtracts it. It's greater than 0, therefore I'll write 46 first, which I write here. Goes down. Then 71. Here, which goes down. And then this will go down. Well, and then this stuff is happening. Hello. Oh, this is 71 again. That's fine. This is minus. Oh, I forgot to fix. That's why. Right? 29. No, it's fine. So what it does, 71 minus 29 minus 71 is 42. Is that correct? Do I have a calculator nearby? I guess I can use my computer. What was it again? 71 minus 20, no wait, is it 29 minus 71 minus 42. Oh, it's in back. That's a problem. That's a huge problem. Boop. So 71. Save that. We want to nullify back. No, we don't. 29 minus 42. Minus 42. It did the swap. It did the swap. So this part seems wrong then. If it's greater than 0, if it's not greater than 0, the accumulator is in a terrible state. It's negated, or just 0 itself. Which means what we want to do is the back that we had, we want. The accumulator we don't want. So what I'm going to do is I'm going to move 0 to the accumulator, then I'll swap. And then that's like saying, yeah, I think that's good. That's like saying, it's like resetting the accumulator. So 29 is a good value. 29. Yeah, 90 minus 66. 90 minus 66 is 24. So what happened? So where did it get that 29 from? So what's it gonna do? It's gonna do... It's 29 minus 4 and minus 71. Yeah, that's perfect. And then it'll swap. Then it'll say 29 down. And then it's gonna say 66 right down. And then it has to jump to the start of the program. Eitherwise. There you go. I'll just fast forward it. There you go. So that was 142 cycles, 4 boxes used. I guess they're called nodes. Yeah, nodes, and 20 instructions. 142 cycles. I mean, that's pretty good, I think. Because my last 2 ones were pretty bad. But this one's pretty good. I mean, let me see. Is it any other way of making it more efficient? I don't think so. Yeah, this let me just yeah. Let me look here. Boom. So 7979. Was that written already? Yeah, it's written already. Let's boop. There we go. Wait. 79. Because it's the same, 0 doesn't matter. Yeah. I mean, I think that's good enough. Yeah. It does 1 conditional check. Sub left, save. Boom. This 1 conditional check. And it does like 3-4 instructions. It resets accumulator to 0 because I need to swap it. There is a way to make it slightly more efficient. Instead of starting the program here, looping the program here, I'll loop the program here. And instead of doing this useless operation, I'm gonna do a useful operation. No, that was terrible. Oh yeah, no. Move up accumulator. 0. I'm writing 0. Why is this bad? It's because I'm accepting 90. And then the back isn't used. Hold up. Was I wrong? No, the swap. Was the swap even necessary? Like, was that necessary? This back is a terrible state. But because we will be saving it here, it doesn't matter to us. Yeah, I was under the impression, continue editing, that the swap was necessary. So what did I change? I don't even remember. Oh, I think I forgot to jump. That's what I did. I forgot to jump. Yeah. Okay, that saved us an instruction. So is there anything else we could do? We save it. We take it away. We will jump. 3 simple things. Okay. Swap. Yeah, but we can't swap before the condition. It'll be the same amount of instructions, but it'll just be 1 instruction less in total if we somehow could swap before it. But this will be checking the accumulator. We can't swap it just yet. So therefore we'll have to swap individually. Uh, yeah, or else I'll have to jump back. So we'll swap it individually. And then this does a similar thing, except it's just the other order. I think this is good enough. So this is what, 132 cycles, 19 instructions, 4 nodes. Pretty good, I think, all things considered. So that's my solution to the, what is it, 6th part now. Thank you.